The third type of applications that we encounter involve trigonometry and transcendental functions. Here we're asked to evaluate the limit as x approaches 0, sine x times 1 minus cosine x over x squared. And plugging in 0, we have cosine of 0 is 1, 1 minus 1 is 0, sine 0 is 0, 0 times 0 is 0, over 0 squared is 0 over 0. And x squared is a polynomial function. It is everywhere continuous and differentiable, so uh, that's good. Sine of x times 1 minus cosine of x is this, even though it is a product, each of these functions are themselves continuous and differentiable over all real numbers, so therefore their product is. We can apply L'Hopital's rule. So we do this. But I'm thinking about this, and I'm thinking about applying the product rule to this and how this could get messy and long pretty quickly. Is there something else I can do? And you know, all that time that I spent back in Unit 1 doing these types of limits by hand without L'Hopital's rule, I did learn a few things that will help me even now. For instance, I might begin by splitting this up as the product of two different limits and then checking those. So let's try that. So we have the limit as x approaches 0, sine of x over x times the limit as x approaches 0, 1 minus cosine x over x. And you may be thinking, well, this looks familiar. I bet I have some trick that I can use to handle this. Well, yes, we do, but we're not going to use those shortcuts. We have to use L'Hopital's rule because this is a L'Hopital's rule problem. Okay, what can we do? Well, if you forget that the limit as x approaches 0, sine x over x is actually 1. If you forget that, if you forget that the limit as x approaches 0, 1 minus cosine x over x is actually 0. If you forget both of those rules, but you remember L'Hopital's rule, you're saved in this situation. Because look what happens. If you plug in 0, we get sine of 0, which is 0 on top, and 0 on the bottom, an indeterminate form, times 1 minus cosine of x of 0 is 1, 1 minus 1 is 0, and 0 on the bottom. So both of these satisfy the criteria for L'Hopital's rule, and I can apply L'Hopital's rule to each of these products. So let's do that. Limit as x approaches 0, the derivative of sine is cosine x, and the denominator now is just 1 because the derivative of x is 1, and that's going to be multiplied by the limit as x approaches 0, 1 minus cosine x. Okay, so the derivative of cosine is negative sine, so negative times negative is a positive, sine x. And again, the derivative of the denominator is just 1 since it's x. And so now I can evaluate these limits directly. Cosine of 0 is 1 times sine of 0 is 0, and 1 times 0 is equal to 0. So that's what this is equal to.